In the last lecture, we left off with the exact value chart, and we were talking about the unit circle and the fact that the sine of, let's say, 30 degrees is the same as the sine of all of the other angles in the unit circle that have a reference angle of 30 degrees. So I'd like to start with a brief retrospective. So what that means is I'm going to go back to that exact value chart for a few minutes, and then we're going to go even further back to the very first lecture where we talked about how to find all 6 trigonometric functions given a single trigonometric function. Okay, so we're going to briefly revisit that, and then we're going to look at the graphs of all of the trigonometric functions. So let's start with that exact value chart. So if we take a look at it, this is what it was, okay? And we said these are the angles at the top. These are the angles in radians. You should be very familiar with that. Okay, so we haven't done a tremendous amount of work with radians, but when we get to trigonometric equations, which is coming up soon, you're going to be working with radians a lot more than you will be working with degrees. So you should become familiar with that. But we said, okay, so we have 0 degrees, 30, 45, 60, and 90. These are angles that we know the exact values of, meaning we know the exact value of the sine, the cosine, and the tangent. Okay, note that we would also know the exact value of the cosecant, the secant, and the cotangent because they're just the reciprocals. So for example, if the cosine of 0 is 1, the secant of 0 is 1 because the reciprocal of 1 is 1. If the cosine of 60 is 1/2, the secant of 60 is 2 because the reciprocal of 1/2 is 2. If the cosine of 90 is 0, then the reciprocal, the secant of 90 is undefined because 1/0 is undefined. If the cosine of 30 is square root of 3/2, then the secant of 30 is 2 over the square root of 3, or 2 square root of 3/3 if we rationalize the denominator. Okay, so you can see that we could figure out all 6 of the trig functions. Okay, let's go back though and look at other angles that have the same reference angle. Okay, so we're looking at the sines, cosines, and tangents with the same reference angle. And we discussed reference angles in the last lecture as those in the exact value chart. So when we introduced the exact value chart, we were saying, well, once we know the sines, the cosines, and the tangents of reference angles, then we also know the sines and the cosines and the tangents of any angle that has the same reference angle. So let's take an example. Let's take 30 degrees. And we won't do this for all of them, but we'll do it for most of them. So if we have 30 degrees, okay, then based on the exact value chart, we know that the sine of 30 is 0. Sorry, sine of 30 here is 30 degrees. Sine of 30 is 1/2. Cosine of 30 is square root of 3/2, and the tangent of 30 is square root of 3/3. So let's just write that down. Sine of 30 is 1/2. Cosine of 30 is square root of 3/2. And the tangent of 30 is 1 over the square root of 3, but if we've rationalized the denominator, that gives us square root of 3/3. Okay, now what does this mean? There are other angles that have a reference angle of 30 degrees. So for example, in quadrant 2, if this is 30, then the angle is 180 minus 30. This angle here is 150 degrees. Okay, 150 degrees has a reference angle of 30 degrees. So what does this mean? Well, in quadrant 2, so we'll go back a little further. In quadrant 2, the sine is positive, the cosine is negative, and the tangent is negative. So what does this mean? This means that the sine of 150 degrees is going to equal the sine of 30 degrees. They're the same in both quadrants. The sine is positive in both quadrants. So the sine of 150 is 1/2. Now the cosine of 150, well, in quadrant 2, remember in quadrant 1, everything is positive. Okay? In quadrant 2, the cosine is negative. So this would be the negative cosine of 30 degrees. Or negative square root of 3 over 2. And the tangent is also negative in quadrant 2. So the tangent of 150 is the negative tangent of 30 degrees, or negative square root of 3 over 3. Now we could look at the same thing in quadrant 3. So in quadrant 3, the angle, if this is 30 degrees, okay, the angle that's equivalent to 30 degrees, which would come all the way around like this, that angle is 210 degrees because we're going 180 degrees around plus an extra 30. Okay, so what does this mean? Well, the sine of 210 degrees in quadrant 3, the sine is negative. So the sine of 210 degrees is negative sine of 30. Or negative 1/2. So we know that the sine is the same as the sine of 30. We just have to figure out, is it going to be a positive number or a negative number? So in quadrant 3, sine is negative, so it's going to be negative 1/2. In quadrant 3, cosine is negative. So it's going to be the negative of the cosine of 30, or negative square root of 3 over 2. And the tangent of 210 degrees in quadrant 3 is positive. So it would be the same as the tangent of 30 degrees. So tangent of 30 is square root of 3 over 3. Okay, and then we have the same angle in quadrant 4. We'll do that one in green. We have a reference angle of 30 degrees. So we have 4 angles that all have the same reference angle. Okay. This one, if we go all the way around, this one has an angle of 330 degrees, right? It's just 30 degrees short of 360. So it's 330 degrees. So let's go through it for 330 degrees as well. So the sine of 330 degrees is negative the sine of 30. Sine is negative in quadrant 4. So this would be negative 1/2. Cosine in quadrant 4 is positive. So the cosine of 330 degrees is equivalent to the cosine of 30, or square root of 3 over 2. And the tangent of 330 degrees, well, that's going to be the tangent of 30, the negative tangent of 30, because tangent is negative in quadrant 4. Okay, so again, notice it's all the same numbers. It's just that sometimes it's positive, sometimes it's negative, depending upon what quadrant we are in and what trig function we're looking at. Okay, now we're not going to do this for 60 and 45, but we'll do it for 1 in each of them. Okay, so we won't do it for all 4 quadrants. Okay, so this we did for all 4 quadrants. In quadrant 1, it's 30 degrees. In quadrant 2, it's 150. In quadrant 3, it's 210. And in quadrant 4, it's 330. All of these have a reference angle of 30 degrees. But let's say that we wanted to figure out the sine of 135 degrees. Okay, well, the first thing that we need to do is we need to figure out the reference angle. So 135 is between 90 and 180. So to figure out the reference angle, we're in quadrant 2. We do 180 minus 135. And we get a reference angle of 45 degrees. Okay, so now we know that the sine of 135 degrees is equal to the sine of 45 degrees. We just need to figure out, is it positive or is it negative? Well, 135 degrees is in quadrant 2, and in quadrant 2, the sine is positive. So this is the sine of 45, which is square root of 2 over, that does not look like a 2, square root of 2 over 2. Okay, if we go back to our exact value chart, you can see the sine of 45 is square root of 2 over 2. Okay, let's say that we wanted to find the tangent of 300 degrees. Once again, we have to find our reference angle first. So 300 degrees is in quadrant 4. In quadrant 4, we take 360 and we subtract the angle. So we get 60 degrees. Okay, so this is telling us that the tangent of 300 degrees equals the tangent of 60 degrees. But in quadrant 4, tangent is negative. So it's the negative tangent of 60. And the tangent of 60 is square root of 3. So the tangent of 300 degrees is negative square root of 3. Let's do one more. Let's say that we want to know the cosine of 240 degrees. Okay, so once again, we want to find our reference angle first. So 240 is in quadrant 3. Okay, how do we know that? Because it's between 180 and 270. So in quadrant 3, we take the angle and we subtract 180 degrees. (240) minus 180 gives us 60 degrees. So we're saying that the cosine of 240 degrees is equal to the cosine of 60 degrees, but it's negative because in quadrant 3, cosine is negative. So the cosine of 60 is 1/2. So that means that the cosine of 240 is negative 1/2. So we have a lot of angles that we could figure out. The reference angles that have a reference angle of 45 degrees are 135 degrees in quadrant 2. In quadrant 3, it's 225 degrees. In quadrant 4, it's 315 degrees. So we could find the sine, the cosine, and the tangent of all of those angles. For 60 degrees, sorry about that. For 60 degrees, the reference angle, the angle in quadrant 2 that has a reference angle of 60, is 120 degrees. In quadrant 3, it's 240 degrees. And in quadrant 4, it's 300 degrees. Okay, so we can find the sine, the cosine, and the tangent for all of those. And then for 30 degrees, you see it's 150, 210, and 330. Now for 0 and 90, okay, 0 and 90 are not considered reference angles because reference angles are acute angles, and these are not forming angles at all. It's just two lines. We can't call them acute angles. But for 0 and 90, we could figure out the sine, cosine, and tangent based upon what we know about the unit circle and the fact that the unit circle, our coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And if you remember, at each of those angles, we know that the sine is the y value and the cosine is the x value. And we're going to be using this to help us graph. So we're going to come back to that. But that means that we can figure out the sine and the cosine not just of 0 and 90, but also of 180 and 270, because we could just look at the coordinates over there. So we could figure out the exact values for sine, cosine, and tangent of a lot of different angles. Okay? For all of the other angles, we don't know the exact values. Okay? But if it says exact value, it means no decimals. Okay. So one other thing to look back on is in our first lecture, we said, okay, well, what if we know that the sine of an angle is 3 over 7? What is the cosine, the tangent, and the cotangent, the secant, the cosecant? We were asking about all of those things. So I want to take an example and add in what we know about these angles, okay? The fact that we're in the second quadrant, the third quadrant, and the fourth quadrant, and whether the sine is positive or negative, okay? So let's take an example. Let's say that we know if sine of theta is equal to 3 over 5, and it terminates in quadrant 4. So it's actually negative 3 over 5, because sine is negative in quadrant 4. Let's find, we won't find all of them, let's find the cotangent of theta and the cosine of theta. So we don't have to find all of them, we'll just find those two. So our process here is the same, okay? Nothing is going to change. If you remember our process, we identified the opposite and the hypotenuse, okay? We identified that because sine is opposite over hypotenuse. So the 3 we found was the opposite side, and the 5 was the hypotenuse side, okay? So opposite is 3, hypotenuse is 5. And we said, okay, we can find the adjacent using the Pythagorean theorem. So we need that third side. This should look very familiar to you because we've done it before. Okay, this came from the end of the first lecture. So O squared plus A squared is equal to H squared. This is the Pythagorean theorem. And we're just plugging in 3 squared plus A squared is equal to 5 squared. 9 plus A squared is equal to 25. And then A squared is equal to 16. So A is equal to 4 if we take the square root of both sides. Okay, so now we have all 3. Now we want to know the cotangent of theta. So cotangent is adjacent over opposite. These are things that you should know. You should memorize. These are definitions. There's no way around it. You have to memorize, okay? So cotangent is adjacent over opposite, but we're talking about quadrant 4. So we have to take into consideration, is cotangent positive or negative in quadrant 4? Well, if tangent is positive, then the cotangent is positive. If tangent is negative, then the cotangent is negative. So in quadrant 4, okay, sine is negative, cosine is positive. This means that tangent is negative. So cotangent is negative. So our cotangent is going to be negative 4 over 3. And we say it's negative, once again, this is negative because tangent is negative in quadrant 4. Okay. Whatever the trig function is, that's what the reciprocal trig function is. So if cosine were positive, then secant would be positive. If cosecant were negative, if sine were negative, cosecant would be negative, okay? So we found the cotangent of theta. Let's find the cosine of theta. So cosine of theta is adjacent over hypotenuse. And we're at quadrant 4. In quadrant 4, cosine is positive. So we could just say that this is 4 over 5. It's positive because cosine is positive in quadrant 4. Okay, let's take another example. So notice that the fact that it's saying that theta terminates in quadrant 4, the only extra step that you have to consider beyond what we did in the past is your trig function positive or negative? If your trig function is negative in that quadrant, then you're going to make your answer negative. If the trig function is positive, you're going to make the trig function, you're going to make your answer positive. Okay, now this is one way to ask this question. I'm going to ask it in a slightly different way. Let's say if the cosine of theta is equal to 5 over 10 and tangent of theta, let's make this negative 5 over 10. And tangent of theta is greater than 0. Find cosecant of theta and cotangent of theta. Okay, so what's the difference? The difference is we're not told where theta is terminates directly, okay? It doesn't say and theta terminates in quadrant. This is saying, okay, our cosine is negative. So where is our cosine negative? Our cosine is negative. This tells us theta must be in quadrant 2 or quadrant 3. Okay. But this is saying that the tangent of theta is greater than 0. So this is narrowing it down to one quadrant. Okay. Tangent of theta is greater than 0. Where is that true? Out of quadrants 2 or quadrant 3. So from quadrant 2 or quadrant 3, the one where the tangent of theta is greater than 0 is in quadrant 3. So we would be looking only at quadrants 2 and quadrants 3 because our cosine is negative, okay? And which one gives us a positive tangent? Quadrant 3. Okay, so now we can find the cosecant and the cotangent. So we have to identify our opposite, our adjacent, and our hypotenuse. We know that this is the adjacent and this is the hypotenuse. So O squared plus 5 squared is equal to 10 squared. Or O squared plus 25 is equal to 100. O squared is equal to 75. O is equal to the square root of 75, which is 5 root 3, right? This is square root 25, square root 3. So O is equal to 5 root 3. You want to reduce it? You're going to have to reduce it anyway when you give your answers, okay? So cosecant of theta. Well, cosecant is hypotenuse over opposite. And this is telling us it's 10 over 5 root 3. Okay. 10 over 5 root 3. Now we can reduce this, okay? You can reduce it in, because 5 goes into 10 twice. So this becomes 2 over the square root of 3. And we should mention before we even rationalize this denominator that the cosecant here is negative. In quadrant 3, okay, sine is positive, sine is negative, so cosecant is negative. So these have negative signs. And then we want to rationalize the denominator, so it becomes 2 root 3 over 3, okay? This is how we've rationalized. So that's cosecant. Let's find cotangent. So cotangent is A over O. Our A is 5. Our O is 5 root 3. Okay, and cotangent is positive here. Okay, it's positive because tangent is positive. So whatever reciprocal, the reciprocal functions have the same sign. This we can abbreviate to 1 over root 3. The 5's cancel. And then once again, we can multiply by root 3 over root 3. And we get square root of 3 over 3. Okay, so I'm not going to do a lot of examples here because we've done it. What this piece does is it tells us which quadrant we terminate in. Okay, so it gives us this information. And again, knowing this information, the only thing extra that we have to do, other than what we did in the first lecture, is figure out if that trig function is positive or negative. And we're just going back to that idea of in quadrant 1, is sine, cosine, or tangent positive or negative? What about quadrant 2? Okay, and that has to do with the x and the y values.